All right, so let's get started. Hi, everyone. How's everyone doing today? It's bright and early here, Thursday morning in Canada. My name is Paul Turner, and I help people and projects succeed at commissioning. So today, I thought we'd talk a little bit about some experience I've had on a recent project related to HVDC commissioning. It was a multi-billion-dollar project that spanned over many years, and we were able to complete it on time and on budget. It was a huge undertaking. A multi-billion dollar project like that is on the scale of many huge projects that make up one big mega project. So I'll share some of my experiences and hopefully you find it useful. So we'll first go through some of my background and what I've been working on related to commissioning. I'll go through my experiences for HVDC commissioning and startup. I'll let you know where you can find my free training course, and then at the end, we'll have a live question and answer period. So we're broadcasting on maybe LinkedIn. We're maybe having some technical difficulties there, but for sure on Facebook and YouTube. So you can tune in and watch the replay on Facebook and YouTube once we're complete here. We'll be responding to questions from all those platforms, so we'll be gathering them up, and at the end in a live Q&A, I'll be going through each of those comments that are submitted. So as I'm going through the presentation here, if you think of a question, enter it into the chat box, and we'll record it so that I can answer it at the end of the presentation. As well, we regularly host these live webinars, so if you have any topics that you think might be worthwhile to cover in a future live webinar, please enter it in the chat box and we'll see if we can cover it in one of the upcoming webinars. Also, there's our participation certificate available for this webinar, and I'll tell you how you can access that certificate at the end of the live Q&A. So a little bit about me before we get started is I have 20 years of experience working on complex projects. I'm a professional engineer and a registered project management professional, and I have a wonderful family. We love to travel. This is a picture of us in the Columbia ice fields in Western Canada. I've worked on several complex projects over the years. In the aerospace industry, I've built satellites and rockets for the Canadian Space Agency, as well as payloads for the International Space Station. With regards to power generation, I've worked on a 200 megawatt hydroelectric generating station in northern Canada. Power transmission, I was the commissioning manager for a 2300 megawatt HVDC link, which was a multi-billion dollar project delivered on time and on budget. And that's the project that we're going to discuss today. And some of my experiences related to that project. And currently, I'm the commissioning manager for a wastewater treatment plant where we're upgrading and expanding the existing facilities to meet new biological environmental licenses. So we'll start with a short video here that is a bit of an introduction to the HVDC project that I've worked on. All the information that I'll present here is publicly available. I won't be able to share any proprietary information, of course. This video that I'm going to show you is available on YouTube. It was produced by Siemens towards the end of the project. So we'll just go through that and then continue the discussion.
Manitoba Hydro's Bipole 3 is the largest high voltage direct current project in North America in 30 years. This project has the capability to transport more than 2,000 megawatts of energy highly efficiently over 1,400 kilometers.
Siemens is one of the major HVDC players in the world. The key delivery scope for this HVDC project is the unique and very high-level technology in terms of control and protection. It is the highest reliability requirement because the harsh environmental conditions and complex design. Siemens and Mortensen, our consortium partner, developed the two most important elements of the BIPO 3 project. These two elements are northern station, the converter station, and the southern converter station. Manitoba Hydro is a very unique end customer. They have tons of experience gathered worldwide. We successfully jointly deliver this project on time and on budget.
This project has been a truly collaborative effort, not only between the consortium partners Mortenson and Siemens, but also with our customer Manitoba Hydro, who spearheaded this huge and technically challenging undertaking. The Bipole 3 HVDC project will significantly enhance the reliability of the Manitoba electric system. It will create new revenue generation possibilities for the province and support local communities. And that's ingenuity for life.
So that's a brief overview of the project. Siemens did a pretty good job with that presentation, and if you'd like to check it out again, you can see it at their YouTube site on that link that's in the presentation there. So if there's one thing that you get from this webinar, it's that you need to start with the end in mind by preparing for commissioning at the beginning of the project. This will set your project up for success to deliver your commissioning project on time and on budget. And when it comes to the case of a multi-billion-dollar project, it really requires a very specific approach and a specific procurement process in order to execute a project of this magnitude. You can't simply just take your past contracts that you've worked on and modify a few things and put it out for tender. It really requires a blank sheet of paper to approach it from a blank perspective and see what makes sense specific to this project. And that's exactly what the project team did for Bipole 3. And I commend their huge efforts and their great execution on the procurement process. That's really what set the project up for success, was to do it properly, thoroughly, and correctly right from the beginning of the project. I was able to work with some of the best HVDC experts in the world for preparation of the technical specification and the procurement documents, the legal procurement process, and it was extremely well done. It went very well from that perspective. A large focus up front was based on a detailed performance-based technical specification. And it was a very detailed contracting strategy to provide the best value for the project. This upfront effort and precise procurement process set the project up for success right at the beginning and is one of the critical success factors in making the project a success. This upfront effort also included all the commissioning criteria in the contract document. So you can see that everybody started with the end in mind and included a lot of the commissioning details up front in the procurement process, which was a huge benefit to the project and definitely set it up for success. And I definitely commend the Bipole 3 project team for a precisely executed procurement process that enabled the project to be successful. Without that upfront work, it would have been very difficult to execute commissioning successfully. So some of the first aspects that involved commissioning team was, or the hands-on of the equipment related to commissioning, was some of the factory acceptance testing. So there's a lot of large equipment involved in an HVDC system like this, particularly lots of electrical equipment. So all of the equipment went through factory acceptance testing related to the HVDC equipment, the 230 kV AC switchyard apparatus, the synchronous condensers, as well as all the control and protection software. All of the AC and the DC apparatus was all factory acceptance tested, particularly related to dielectric testing. It all went through third-party testing to confirm that all the dielectrics were correct before arriving to either of the converter station sites. Um, as well, several transformers on the project, so all the AC and HVDC transformers all went through an extensive factory acceptance test program to know that when those equipment arrived at site, that they were going to meet contract requirements. Several large rotating pieces of equipment related to the synchronous condensers, and that all went through an extensive mechanical factory acceptance test in the factories where those large components were manufactured. One of the biggest focuses was on the HVDC control and protection software. We went through many months of factory acceptance testing on the control and protection software, and this was, I guess you would refer to this as an integrated factory acceptance test because this was the actual control and protection panels for both the north and the south converter station, all integrated together in the same room. So it was many panels, tens and tens of panels. There's something like 50 or 60 panels. They're all integrated together in a test environment. Then as well, the actual proprietary control and protection software was programmed into the cubicles as well. So this allowed a very thorough test setup to test both the hardware and the software for the HVDC control and protection. Some of the remote devices would have been simulated where applicable in order to test the hardware and to particularly test the software. But what this test setup allowed the team to do was to actually simulate high power transfers through the system to confirm operation of the software as well as the hardware, all the stability controls, all the control functions. And this took place over several months. There was many months of this factory acceptance testing related to the control and protection software to test all the normal operating scenarios as well as all the fault conditions. Functional performance tests were included. All of the dynamic performance testing was included, and all the stability control functions were tested as well. So the actual hardware and the actual software were thoroughly put through their paces to test all aspects of the hardware and software design. So this was hugely beneficial to the commissioning process because we knew that all the hardware and all the software was fully confirmed to be functional before it even left the factory. So there was certainly lots of pressures to deliver the equipment to site, but this process through factory acceptance testing was hugely beneficial. It was one of the important parts of the commissioning process to confirm that everything was going to work on site. And I can't stress enough that proper factory acceptance testing can't be skipped. Factory acceptance testing is definitely an important function of commissioning and startup and needs to be thoroughly implemented into your project so that you know that the hardware and the software design is correct before it arrives at site. It would have been a much different story had a lot of that testing taken place at site. As issues were being discovered during the critical path commissioning activities, there would have been much more delays, whereas all of that work was done up front to know that what was being delivered at site was designed and would operate correctly. At that point, really, then when we're going through testing on site, it's not so much testing the software and the cubicles, it's more so testing the wiring and the interconnection of all the equipment, since that's the only new part, rewiring and reconnecting the cubicles on site. So that was something that is hugely beneficial to commissioning, and I can't stress enough that thorough factory acceptance testing is hugely beneficial to your projects. So the in-service date of projects is always a very important aspect to consider on projects. If the ISD is not met, there are operational and financial impacts to consider, and this project was no different. The in-service date must be met so that the reliability of the systems can be implemented. The commissioning team plays an important role in in the project by working backwards from the in-service date when preparing the commissioning sequence to determine when all aspects of the project are required to be complete. So on a multi-billion-dollar project, there are many aspects to consider. So what systems are required in advance of others, and when is each subsystem or system required? So if we go through the systems here involved in this project, the 230 kV AC switchyard systems were the first portions of the project that were required. They were required in advance of the HVDC systems because they were required to provide power to the northern HVDC systems as well as receive power from the southern HVDC systems. So the AC switchyard systems were the first portion of the project that was handed over from construction to commissioning and the first focus of getting those commissioned and placed into service. On each AC system, there's again several components of that system and multiple high voltage interfaces as well as several control and protection interfaces, all to be coordinated in sequence into the project commissioning sequence. So you can think of the complexity of managing thousands of interfaces at two different sites in order that the project comes together in the proper order. A huge amount of moving pieces and lots of fun to plan and coordinate. We had a great time. The next systems that were required were the synchronous condensers. So they were required in advance of the HVDC systems to provide support for minimum loading of the HVDC system. And again, there were several high voltage interfaces and several control and protection interfaces that had to be planned and coordinated in order to be available to support the overall commissioning sequence. Then the last portion, the HVDC systems made up of the DC switchyard valve hulls, building auxiliary systems, and all control and protection systems. And these were all needed to be available in the correct sequence to support the commissioning process. So looking at all these pieces of the project, development and coordination of the overall commissioning sequence to achieve the in-service date was an important task of the commissioning team to develop that overall commissioning sequence and provide that feedback to the design and construction teams to help them align their priorities in installation activities. So by knowing that certain portions of the AC systems are required prior to certain portions of the synchronous condensers required prior to certain portions of the HVDC system, that helps the construction team to determine their priorities and sequence of tasks in order to align the construction and commissioning activities. It is critically important to have an integrated construction and commissioning schedule so that construction activities line up with commissioning activities in order that the overall project sequence is achieved to meet that in-service date. This overall commissioning sequence is one of the main reasons to have the commissioning team involved early in the project, because development of the commissioning process should be done early to provide those priorities to the construction team, to the design team, so that everyone is aware of the deadlines they are working towards to achieve the project in-service date. So each construction milestone was defined as a mechanical completion. Large systems of the project were broken down into several mechanical completions. For example, the AC switchyard, one at each end of the project. These are large projects on their own. And a single milestone saying AC switchyard complete isn't necessarily helpful to everyone. We broke those down further to say, okay, here's one of the 230 kV high voltage interfaces, and we'll indicate that as one mechanical completion. So this was the process called systematization of the project, where we took each component of the project and broke it down into several separate mechanical completions. In the example of the AC switchyard, each 230 kV three-phase interface was indicated as one mechanical completion. Then that mechanical completion package would be defined on what that handover includes and when it's required in order to collaborate with the construction team to work out when it's complete and how it's going to be handed over and tested with the commissioning team. So the commissioning sequence defined which 230 kV bay was required first, um, to help align some of those construction activities, and then each bay was handed over in sequence over a few months as commissioning of other aspects of the project proceeded. These mechanical completions took place over about a 6-month period, while commissioning was starting on, say, the AC systems and work was still taking place on HVDC systems. There was definitely an overlap of when some of the earlier systems were available for commissioning and subsequent construction activities were still taking place. Mechanical completions were critically important from a safety perspective as well, because certain systems were being commissioned and others were still being under construction. The mechanical completion defined which group had care, custody, and control of the equipment, so that if one system was under test, the boundary isolations between that system and an area that's still under construction definitely had to be defined. Boundary isolations were very important to define to keep everyone safe with proper lockout, tagout procedures and definition of where those boundary isolations occur in order that everyone knows their limits of where they can work and where they cannot work. So following each mechanical completion, we moved into pre-commissioning, and since a thorough factory acceptance test was conducted, pre-commissioning was largely consisted of verifying there were no installation errors. Wiring was a big focus during pre-commissioning. This consisted of several point-to-point checks as well as meter checks to confirm that all power cabling and all control and protection wiring was installed correctly. All signal checks were complete to verify polarity and that all terminations on terminal blocks were correct. Since the software and control cabinets were all verified in the factory, the main source of error could be outside the cubicle. This would be the wiring between each cubicle. And thankfully, a thorough pre-commissioning program was established, and there were really very few wiring errors that were discovered during commissioning. A few minor errors, but generally everything turned out pretty good due to a thorough pre-commissioning and investigation of all the cabling and wiring. So as well, all the communication and loop checks were confirmed to verify cubicles were communicating with each other. As well, there was lots of interfaces outside the station to central control as well as the other converter station. All the interfaces within the station were verified with regards to connections to HVDC AC systems, synchronous condensers, both on-site and off-site. Everything was verified as part of pre-commissioning phase, leading into commissioning. And an important interface was the communications to the central control operator. This was extensively verified to ensure the correct status and control was in place prior to startup of the systems. Following pre-commissioning, commissioning of the HVDC systems could take place. All the commissioning procedures were written well in advance of the commissioning phase, and this was the point in time when they would be executed during commissioning. Commissioning included verification that all correct control and protection settings were applied and that they all functioned correctly. Control and status to the local control room was verified extensively to the HMI screens in the control room, as well as all the interfaces to the central control operator were extensively verified. The commissioning phase was really the process of getting all the systems ready for first energization during the startup phase. So on a project of this magnitude, there's several startups that exist on the various systems. So the first systems that were energized were the AC switchyard systems, and they were energized in stages to align with each mechanical completion that was defined earlier in the project. Startups were occurring at both converter station sites simultaneously, concurrently. There would be some days where we would energize a system in the south in the morning, and then in the afternoon we'd have another energization in the northern site. And this all had to be closely planned and coordinated amongst both sites particularly as related to the central control operator, where they were the ones responsible for providing power and energizing new systems into the existing bulk electric system. This is a very controlled and methodical approach that needed to be taken to make sure that energizations are done safely and that new systems do not present any risk to in-service equipment. Each startup occurred in sequence over a 6-month period until the final HVDC startup took place. The final startup included first power transmission through the HVDC transmission line, and this was a very important milestone because all portions of the project, all the converter station, all the sites at each station, as well as the HVDC transmission line, all came together for the first time, and it was a huge milestone to see power flowing down that transmission line for the first time. Everyone was very pleased. Achieving this milestone then allowed us to proceed with full system testing, and that took place over a 3-month period to verify all the system tests prior to placing the system into commercial service. One aspect that was considered quite extensively during each of these startups was cybersecurity. This was very important. In North America, the regulatory authority is called NERC, and they govern cybersecurity in North America. So in order to bring a new system into the existing bulk electric system, it had to be demonstrated to be NERC compliant before it's added to the existing system. And this was so that the new systems aren't presenting any vulnerabilities that add risk to existing in-service assets. So there was a large focus on cybersecurity during this project. And cybersecurity is really a complete topic on its own. We could probably discuss cybersecurity for quite a while, but let me know in the chat box if this is a topic that you're interested in, and maybe we can include that for a future live webinar. So another important aspect of the project was operational readiness. It was a huge project, so there was definitely a focus put on getting the operators that were going to operate and maintain the new facilities for years to come up to speed so that they're comfortable with the new systems and able to continue with effective operation and maintenance of the new facilities. And so there was definitely a big focus on operational readiness to have that knowledge transfer to the operating team. With multiple sites and multiple operating teams, this was important to ensure that individuals were ready for continued operation and maintenance of the new facilities. The northern site required a little bit additional planning given its remote location. The best thing that was done was the operations team was embedded as part of the commissioning team. And this was a huge advantage for the project because the commissioning process benefited from operations input to the commissioning activities. Operations was able to learn valuable knowledge from the commissioning process that they could learn and understand the systems going forward. And the individuals involved had a vested interest in the commissioning process, knowing they would be responsible for eventual operation and maintenance of the systems. So that's a bit of a brief overview of some of my commissioning experience related to HVDC. I'll maybe just mention that if you'd like to learn more about the commissioning and startup process, if you haven't already, please join our free 3-day mini course. The course is free and flexible to take anytime online. It gives you a pretty good start so that you can understand or have an early understanding of the commissioning and startup process. And you can get started at www.commissioningandstartup.com. So let's go through some of the live questions that have come in through the discussion here, and I'll answer the questions, or if you've got any more, please add them in the chat box, and we'll hopefully be able to get through them all. So the first question we have is from Raul. I will be a part of the team as an electrical commissioning engineer. What are the questions I need to know before I step into this role? So if you haven't already, a good overview is the 3-day commissioning course that I just suggested. But assuming you've taken that, then the first thing you'll want to get your hands on when you get to site is probably the contract, particularly the technical specification. That's going to give you an idea of the project and the scope of work that's required, and give you some of the bounds of how the commissioning team can operate within scope, schedule, budget of the project. Particularly as an electrical engineer on the commissioning team, you're going to want to get familiar with the electrical systems, and probably the questions to ask is how is it going to be systematized? If that's you defining that, or if that's someone else on the commissioning team, you're going to want to establish how are the electrical systems going to be grouped as subsystems or systems, and how are they going to be handed over from the construction team to the commissioning team, because that's really going to set the priorities of which systems to focus on first before you go out into site and start commissioning. That's also going to guide you in what additional documentation you're going to require with regards to checklists and commissioning procedures for commissioning in the field. So what other questions, or let's assume, what other information do you need to know before you step into this role? Um, in the case of electrical, then the single line diagrams are really going to define the system, and that's a good place to start. And any any of the systems that exist on the project, if you have any of the technical background on those systems, that's going to definitely help in your commissioning role. But there's not everybody can be an expert in everything, so there's going to be some systems maybe that you're not quite as familiar with, and that's where you likely want to or need to determine who else on the project team forms part of the commissioning team, particularly if there's consultants involved or other subject matter experts that you can bring in that are experts in a particular piece of equipment. Then that's going to guide you and assist you in commissioning some of those electrical systems. So I hope that answers your question, Raul. Question from Haru. Testing of protection relays belongs to commissioning or pre-commissioning activity? So the testing of pre-commissioning or of protection relays is definitely a task that's completed by the commissioning team. Protection relay testing is somewhat specialized, and the commissioning team has the expertise and knowledge to commission those devices. This wouldn't be something that the construction team would be as familiar with. They'll certainly install the relay and they'll do all the wiring and cabling from the relay, but then it would get passed to the commissioning team to test the protection relays. So in that regard, installation of the relay and wiring and cabling of the relay would be a construction activity. Then mechanical completion would take place, and then pre-commissioning activities would take place. So testing of the protection relays belongs to pre-commissioning, essentially being the pre-commissioning being verification of the settings on the relay, doing any primary or secondary injections to test the relay. Those would be pre-commissioning activities. Then actually energizing, say, the transformer that the relay is protecting, those would be commissioning activities later. The pre-commissioning would be more so the pre-checks on the relay for settings and primary and secondary injections. Commissioning would be more so the startup and actually use of that relay in the system. So the next question is, I'm interested in HVAC commissioning. Do you have this course also? So I do offer a mechanical commissioning course. It does go into more detail than the 3-day mini course. You can see that course on our website at commissioningandstartup.com. What I do have in there is one of the lessons is specific to HVAC, where it provides several checklists and several procedures that are specific to HVAC systems, and you may find those documents helpful since you can use them as templates to create documents specific to your project. If you'd like to get some more information on that, send us an email. If you'd like to see some of the sample checklists to see what's in there, we could probably share some of those with you as well. Um, we're happy to provide you some information to help you with your HVAC commissioning. Next question I've got is, when will say the plant is ready for commissioning and ready for startup? So the first milestone that we want to achieve on the project is mechanical completion, and that's essentially where the construction activities are complete, and then the care, custody, and control is transferred to the commissioning team upon the signing of that mechanical completion certificate, if you have a certificate like that on your project. That would be really the defining milestone when the commissioning team gets involved. But then the question refers to, when is the plant ready for commissioning and when is it ready for startup? So some of the pre-commissioning activities in the relay example are maybe a good example to use. As soon as we sign that mechanical completion, meaning that the relay is installed and that all cables are installed, pre-commissioning of the relay can take place for verification of settings and primary and secondary injections to confirm function of that relay. Those pre-checks would be pre-commissioning. Then once that's complete, along with pre-commissioning of all other aspects of the system, we're really ready for commissioning and startup. So if that relay is protecting a large oil-filled transformer, we would have gone through all the pre-commissioning checks on all aspects of the transformer for all control and protection, all communication, all checks from the local control room to the transformer, from the transformer to the central control system operator. All of those pre-checks are complete and verified through the commissioning phase. All those devices are communicating and functioning properly as a system. Once we know that the system is functioning correctly and it's going to be able to react to any power disturbances, and it's going to be able to be controlled and the status determined remotely, then at that point we're ready for startup. So that startup would be first energization of that oil-filled transformer with 230 kV power applied. Following that startup is likely a soak period of so many hours, say 24-hour period where the transformer is soaked at 230 kilovolts for 24 hours to confirm thermal properties of the transformer and that everything looks normal after that 24-hour period. That's generally the sequence through mechanical completion, pre-commissioning, and startup phase, and it's going to vary depending on the piece of equipment. There's also going to be multiple milestones associated with various aspects of the equipment for each of those milestones. And part of the commissioning team's role is defining that commissioning sequence up front early in the project so that everybody's working to that commissioning sequence. So I hope that answers your question, Richard. Question from Jester. Can we proceed with the acceptance of the project even if there's a problem encountered in the machine during commissioning? So that may depend on what the problem encountered is, but it certainly could be the case where if there's a problem that's encountered, but it's minor in nature, and maybe there's an operating procedure that can be put in place to be able to work around that particular error, that could be the case. You could list that particular item as a deficiency to be corrected during the warranty period. That allows the system to get into service, assuming that the problem doesn't impact in any major way operation of the system, but it does allow the system to get in service while that particular issue is being addressed. Say the issue was minor in nature, but it was still going to take 6 months to address due to procurement issues. There certainly would be a desire to probably put the system in service and work on that issue in parallel. It would be quite common for minor deficiencies to be noted and to be corrected during the warranty period. Certainly any major issues, if there's a fundamental issue encountered in the machine during commissioning and it does impact operation, then that's something that certainly needs to be addressed. If the system can't go in service safely and reliably, then of course that issue is going to have to be addressed before it's placed into service. But But if not, if it's minor in nature and the system can still be operated reliably and safely, and the issue can be worked around, then for sure that could be an option to uh, accept the project with that noted deficiency to be corrected during the warranty period. So thanks for that question, Jester. I hope that answers your question. Question from Arcturus. I'd like to see training about the performance test execution, ways in which contractors try to steal some extra megawatts for getting the performance contract requirements, like close, open certain valves. So yes, in my experience, the performance test execution is done. I guess the term I'm familiar with would be a performance guarantee period. So during system commissioning, all the system tests are completed to confirm proper operation of the system, but the system may need to run for a period of time to confirm some of the performance guarantees or some of the technical parameters that are required in the technical specification. It's not necessarily something measured, say, in a 1 or 2 day test. The system would need to run for a period of, say, 1 year or 3 years or something to confirm that certain performance guarantees are achieved. So at substantial completion or PAC, provisional acceptance certificate, the system is placed into service, and then there's the performance guarantee monitoring period to confirm certain aspects of the system. So that could be monitoring things like losses of the system or guaranteed reliability of the system based on how many outages are incurred on the system. That performance guarantee monitoring period would measure those items and confirm the actual performance of the system. There may be commercial impacts on what the actual numbers are defined in the contract. If the performance guarantee metrics are met, then there may be commercial implications in that, and even more so if aspects of the performance guarantee parameters aren't met, then there would be commercial impacts in that as well. So I haven't had any experience with contractors that are trying to steal some extra megawatts um, for in order to try and meet the performance guarantee requirements, but I can't say that that necessarily wouldn't happen. That certainly could be something that could exist. In my experiences, it hasn't been the contractor that's operating the system. So the contractor is only monitoring or watching or getting the data from the system. It's been the owner's operators that have been operating the system. So there hasn't been any chance for the contractor to try and manipulate the system. But in some cases, that may not be the case. That once the project goes in service, there's also a contract in place for operation of the system where the contractor or a third party is involved in operating the system. And I guess that could open up situations where they could be changing the system to hopefully, or not hopefully, to somewhat influence the performance guarantee parameters. And I would say that's something that the commissioning team could definitely assist with if obviously not the whole commissioning team, but maybe a few individuals of the commissioning team remain as part of the project to monitor its operation and ensure that those sorts of things aren't happening so that the owner can get proper value out of the system and the performance guarantee period. So I hope that answers your question, Arcturus. So next question. During the actual commissioning of integrated systems, what is the exact sequence to follow during startup? So let's maybe it's similar to one of the examples we've discussed with regards to transformer energization. Let's let's use that example again. So the exact sequence to follow would be let's look at it more on a say a day by day basis as you're getting ready for first energization of the transformer. In advance of that, one thing you're going to want to conduct is a pre-startup safety review. So this would be a checklist prepared in advance so that you have the checklist in hand to know all the things that need to be verified before you start up that particular piece of equipment. The PSSR checklist is an important safety measure to ensure that on the day of energization, all checks are in place before starting that up. So that PSSR would be reviewed, say, 1 or 2 days before energization to make sure that all things are in place. You might note in there that because this is the first energization of a large piece of equipment, there's a particular exclusion area that's required, maybe larger than normal, where things need to have red tape and roped off with red rope and pylons to keep everybody away from the new piece of equipment during that time of when it's energized. It may also note additional personnel on hand, maybe from an emergency response perspective. If there's problems with the unit, then who's available for giving a heads up to the fire crew or whoever may need to respond in that particular instance. So that's the PSSR. Then on the morning of the energization, once that's reviewed, at the morning tailboard, one of the first things that the commissioning team is going to want to do is go walk the system. So a few members of the commissioning team, maybe some from the construction team, will also join and walk through the particular systems related to that energization that morning. So in the case of a large transformer energization, you'd go out and look at the system, confirm that all the piping and valves is in the correct configuration, that all safety guards are in place, there's no exposed electrical hazards, there's nobody working in the area, and that exclusion zones are in place. Walk through some of the other systems maybe that are related to the transformers, the cooling systems perhaps. Walk through any of the systems that are related to that morning's energization to make sure visually that everything looks correct from a safety perspective and also from an operational perspective. Then, if everything looks good, the commissioning engineer will give the authority to apply first power to the transformer. Assuming everything goes correctly, then the system is monitored for a period of time to confirm thermal properties or to allow it to soak for a period of time. If something doesn't go as planned, maybe the transformer trips off, then that's where the real commissioning starts. That's where the commissioning engineer and the commissioning team will get involved to troubleshoot the system and find out what the cause of the error was. Hopefully, it's a minor error. Maybe there was a CT that was wired backwards. But basically, get to that root cause, address the issue, and then determine how to proceed. If it's something that can be corrected in a minor nature, maybe you can still proceed with energization that day. If it's something that has more impact to that system or maybe other areas of the system, a more thorough root cause analysis has to be performed to determine next steps before proceeding with the next energization. So hopefully that answers your question, Robin. So Abhishek is asking, what is the difference between pre-commissioning and commissioning? So pre-commissioning is really the initial checks to confirm that equipment is installed correctly. It's basically to confirm that all the installation is complete and that it's correct. So take the example of wiring or cabling. You want to confirm that all the conductors are on the correct terminal blocks and not wired incorrectly. That would be some of the pre-commissioning to make sure that the system is going to function correctly. Pre-commissioning would typically be done maybe with the cubicle energized, but certainly not with, say, power through the HVDC line. This would be in a much more benign state to do some of the pre-checks of the system. Commissioning then refers to actually getting the system up and running and doing testing on the system as a system. Pre-commissioning, you may be looking at some of the aspects just at an equipment level, like a particular pump or a particular electrical device, where commissioning is getting all the equipment to function as a subsystem or a system. Pre-commissioning, you might be checking out just the motor or the pump itself, doing a bump test on the motor or a polarity check, whereas commissioning would be actually using the motor and the pump along with the piping, pressure valves, chemical dosing skid, and logic controls. Commissioning would involve all of that equipment to see that that group of equipment can function as a subsystem or system. Commissioning basically checks out all the systems leading up to when you want to start up the systems and apply first power, say to a transformer or to an HVDC transmission line. Next question is from Muhammad. I was a CCR operator and being involved in the project. That's right, it was very helpful in my operations career. What should I do to be a commissioning engineer in the future? Where should I start it? Great question, Mohammed, and you're in the right place. You're definitely going to want to learn as much as you can before getting to site and getting involved in the commissioning team. Commissioning, like any profession, I guess, always has a certain terminology and certain acronyms that you want to be able to get familiar with the language and speak the commissioning discussion. So you want to look to online resources and commissioning training to be able to at least get familiar with the concepts, the commissioning process, and the overall steps required to be successful at commissioning. So that's you're in the right place. Check out my site at commissioningandstartup.com. There's lots of great resources. Check out my free 3-day mini course. It's a great place to start. And then if you're looking to advance your commissioning career even further, I do offer more in-depth training. I have a mechanical commissioning course, and I'm just in the process, hopefully in the next few weeks, releasing an electrical commissioning course. And there's nothing, I can't find anything similar to it online. This will be a great electrical commissioning resource that everybody can use, and hopefully you can make use of to get you familiar with electrical and mechanical commissioning. Now, learning through a course is one thing, but it's important to get you familiar with the concepts before you get to site. Once you get to site, then the learning continues for sure. Hopefully, you're able to pair with an experienced commissioning manager, an experienced commissioning engineer to be part of that commissioning team. And that's where the learning continues, is to get that hands-on experience with the equipment at site, become familiar with the systems, and learn from others that are familiar with commissioning to continue your lifelong learning of commissioning and startup. So with regards to your question, Mohammed, where should I start? You're in the right place. This is where you should start. Raul's got a follow-up question. Are there procedures on how to define systems and subsystems in case that will be part of my role? So I've never found a particular procedure or flowchart that would say this is how you define a system. It's it's a bit of an engineering analysis to look through all of the project documentation and determine what is the best commissioning sequence and what components of the project are required in order to build up that commissioning sequence. This is something that I will be including in my electrical commissioning course because it is a question I get asked often. This is really the process of systematizing the project. You can look at a huge, major, multi-billion dollar project and all the components involved, and you need to go through that systematization process to break it down into components of the system and identify in each mechanical completion handover. When you look at the process of how to do that, it's really determined by the commissioning team and what's required in order to build up the system. So you can get 3 components of the project, 3 pieces of equipment, but they're not going to be much use if you require 2 other components. So through the process of systematization, you're going to identify that, okay, these 5 or 6 pieces of equipment make up one of the subsystems in the project, and these are the pieces of equipment that are required in order to proceed with commissioning. Then you're going to group up another section of equipment and say, okay, these dozen items now form another subsystem within the project, and as part of that mechanical completion, they're going to be handed over in that mechanical completion for further commissioning. Each of those subsystems then get tested as a subsystem or system as you're building up the project. So it's really going to be a process of how the commissioning team wants to proceed through commissioning, or what's the most efficient manner to proceed through commissioning, and what components of the project are required in order to achieve that sequence. It's one of the big reasons that the commissioning team needs to get involved in the project early, because then it helps the design and the construction teams align their activities with how the system is going to be started up. Certainly in the design phase, when the design engineers are designing the project, they're thinking in that similar manner. When they're designing the project, they're not just designing each piece of equipment. They're designing this to function as a one complete system. The difference maybe between their thought process and the commissioning team's thought process is when they're designing, say, an HVDC system, that's a huge piece of the project, and the commissioning team may choose to break that down even further into more manageable components that can be executed on site for the actual commissioning process. So the two processes are definitely aligned, and you can start with how the design team has broken out some of the functions with regards to designing the system, but then the commissioning team may choose to break that down even further into make it more manageable at a site level for how it's going to be commissioned. So thanks for the follow-up question, Raul. So Carlos has a question. I would like to know if you can recommend that the professionals that assist with factory acceptance testing should be the same that do protection and control or pre-commissioning and startup. I think that's what you're referring to there. Definitely, yep. So when the design team, it's likely the design team and the procurement team are working in conjunction to specify and procure a lot of the equipment. But when that equipment is being manufactured and it's being tested in the factory, the commissioning team definitely wants to get involved in that process. That's the first opportunity for the commissioning team to see the equipment and to become familiar with it, also to understand any of the issues that are encountered with the equipment during factory acceptance testing. Any issues that are encountered during factory acceptance testing are the first issues that are consolidated and added to the deficiency list for each piece of equipment on the project. So as deficiencies are known, they're hopefully being addressed in the factory, but that's not always the case. Some of them are listed as a deficiency to be corrected at site. And it's hugely advantageous to have the commissioning team at the factory acceptance testing to see some of those deficiencies and know what's working and what's not in order to know what the follow-on tasks on site are to address those deficiencies. So yes, it's hugely beneficial to have the commissioning team actually travel to the factory site, witness some of the factory acceptance tests, so that it's just beneficial for everybody to learn the systems and to have that continuity in any deficiencies that are identified and deferred to be rectified at site. That's not always the best thing to have deficiencies deferred to site, but sometimes it's impossible to avoid. And if you have someone that's aware of that deficiency that's actually going to be addressing it and knows to be aware of it at site, that's hugely advantageous. So thanks for the question, Carlos. Question from Ike. Using the terms interchangeably, pre-commissioning and commissioning, could one have a better clarity with respect to construction and startup stage? Right. So I wouldn't necessarily use pre-commissioning and commissioning interchangeably because they are two very different set of activities on site to get the systems up and running. Similar to what we last discussed with regards to mechanical completion, the mechanical completion is really the first milestone to be met by the construction team that then triggers the start of pre-commissioning. Maybe one thing I'll clarify with regards to mechanical completion is it can somewhat vary depending on mechanical versus electrical. In the case of electrical systems, electrical pre-commissioning is typically executed by the commissioning team, given that it's usually more specialized commissioning, relay testing, requiring specialized equipment and specialized knowledge. So in the case of electrical pre-commissioning, mechanical completion would take place first, followed by electrical pre-commissioning by the commissioning team. Mechanical systems maybe are somewhat different, given that the pressure testing, leak testing, and flushing of the mechanical lines, those would be considered pre-commissioning activities, but those are typically best done by the installer of the piping. So that would be the construction team. As the construction team is installing piping, they're flushing it kind of in parallel before they connect final connections. They're also doing leak testing and pressure testing to confirm that it's installed correctly. Those activities are done by the construction team. Then mechanical completion would take place and hand over to the commissioning team. So in the case of mechanical systems, I would classify that as somewhat different than electrical systems, is that the mechanical pre-commissioning will take place by the construction team, followed by mechanical completion, then followed by uh, testing of or commissioning of the systems by the commissioning team. So following pre-commissioning, then commissioning takes place, and that's, like I mentioned earlier, that's when a group of the equipment functions or starts to function for the first time as a subsystem or system to confirm that everything that can communicate together and everything can operate properly before application of process fluids or before first power transfers or first energizations. So then commissioning leads to startup. Startup would be actually introducing process fluids to the mechanical equipment or having first energizations or first power of the electrical equipment, leading up to final commissioning and handover to the owner. So I hope that hopefully that clarifies for you, Ike. Question from Awaludin. Can you explain further regarding safety precautions during pre-commissioning and commissioning? Yes, for sure. So the two critical safety aspects that should be conducted prior to application of first power or startup of any equipment, be it electrical or mechanical equipment, is the PSSR, the pre-startup safety review. And this is this is a checklist reviewed and prepared by the commissioning team and the engineering team, the construction team. Everybody has input into what is considered during the startup. So anything from a safety perspective related to design, construction, commissioning is identified in this PSSR, and this would be done well in advance of any of the startups because it requires a bit of a methodical thought process to make sure that everything's captured. Then a few days before startup, that checklist is reviewed by all parties. There's probably a meeting that you would plan and schedule in advance with all stakeholders involved in the startup to review the PSSR and confirm that everything's complete. From a design perspective, from a construction perspective, you want to confirm that there's no type A deficiencies that impact the energization and therefore need to be rectified before the startup. That would be one of the critical PSSR items. And that could potentially delay startup if there are items there that are type A deficiencies. They may have to be addressed before starting up the system. So then that PSSR is conducted. Anything that's outstanding needs to be addressed before startup. Any particular exclusion zones need to be put in place so that everything is ready for the day of startup. So then the morning of startup at the morning tailboard, the PSSR is reviewed again to make sure that all outstanding actions are complete. And the first action that the commissioning team is going to want to do with support from maybe the construction team or the design team consultants, whoever needs to be involved in the startup, is to go walk the systems. Confirm that in the case of mechanical systems, there could be valves that need to be in a certain configuration in order for the startup scenario that's taking place that day. Transformers may need to have cabinets locked and closed up, may have cooling valves that need to be arranged in a particular configuration. Anything related to a safety perspective or an operational perspective that needs to be reviewed that morning to confirm that everything is safe to operate and energize for the first time. Then startup will occur and hope everything goes well. If not, then further investigation, troubleshooting is required to diagnose the issue and determine when next energization could take place. If it's a minor error, maybe later that same day, or if it's a more significant error, might require some further analysis by the design team, construction, commissioning to determine next steps on how to proceed. So I hope that answers your question, Awaludin. Question from Richard. As a commissioning engineer or supervisor, what kind of documents need to be brought at site during pre-commissioning of each system, mechanical or electrical system, for plant? A very good question. So the question refers to documents that need to be brought to site. I'll maybe back up even a little bit before then. So before the commissioning team even mobilizes to site, there's several documents that the commissioning team needs to start with planning and coordinating commissioning activities. Obviously, the contract and all the design documentation from the design team is required. But some other documents that are going to be critical from the contractor or the vendor are a lot of the O&M manuals, and probably the most critical documents to get from an output from commissioning are the marked up issued for construction drawings. So these are the red line drawings or the as-built drawings that define any changes that were made in the field, either from a design perspective or from an installation perspective. The commissioning team definitely needs the most current set of drawings that show the actual as-built installation in the field. If the commissioning team doesn't have this, if you're working off the issued for construction drawings, there may have been things that were changed in the field. If there was a terminal block wiring that was swapped for whatever reason, the commissioning team needs to know that. If you don't have a clear definition of what's being commissioned, then it's going to be impossible to verify exactly how the system is operating. So that's probably the most important set, is the accurate as-built drawings. You can start to work from some of the IFC drawings, the issued for construction drawings, to prepare some of your procedures and checklists. But then you're definitely going to want to have the red line markups in hand to confirm anything that's changed and how that may impact any of your checklists or procedures that you put in place. So that's always a challenge. To have that set of drawings early enough to be able to prepare checklists and procedures while construction is still taking place. You're probably going to want a few revisions of that to at least start with the current set of drawings and get an update as things change or any new red line markups are added to the drawings, so that you have the current definition of what's required. So then your question related to what needs to be brought to site during pre-commissioning is the O&M manuals, because they'll provide information on how to prepare some of the standard operating procedures, how to operate the equipment, and you'll definitely want to have those written in advance. And you'll definitely want to have the as-built set of drawings, or I guess red line set of drawings, as well as all the checklists and procedures that you prepared in advance. If you mobilize to site with that set of documentation, that's a pretty good start for having the documents that you need to be able to proceed with commissioning. Of course, there's other aspects related to the commissioning schedule and the commissioning sequence and the order of priorities of how you're going to go through that work. But at the site level of actually executing commissioning, that set of documents related for procedures, checklists, and drawings are probably your most important set of drawings. Related to mechanical drawings, those would be particular the P&ID drawings, piping and instrumentation diagrams. That's going to give you a pretty good overview of the mechanical systems. In the case of electrical systems, those are the single line diagrams, cable lists, and wiring diagrams that you're going to want to have in hand so that you can learn and understand the systems and go through testing of each mechanical and electrical system. So Jester has a question asking, can I request a sample checklist of commissioning and startup? For sure. If you want us to send you a sample, we can definitely give you a sample. If you make the request to support@commissioningandstartup.com, we'll be able to provide you a sample checklist of a particular system. One thing to consider is that checklists are always specific to the equipment that's being tested. So if we send you a specific example, know that in the courses that we offer, there are more detailed and specific checklists that are specific to each piece of equipment. So for example, in the electrical commissioning course that we're working on right now, it would have checklists that are specific to transformer pre-commissioning or specific to pre-commissioning of an electrical distribution system. The one system we're working on right now is checklists for lighting and control systems. So we can send you a sample of a checklist, knowing that there's a lot more resources that are available to you if you like to get actual more specific checklists for specific and electrical equipment that you may be looking for on your project. So send us an email and we'll see how we can help you out. Question from JT, during commissioning time, am I allowed to suggest some special aspect prior to the job? So I'm not sure exactly what special aspect you may be suggesting there, but maybe let's consider some sort of design change that could maybe make the system better or maybe make the system more easier to operate and maintain in the future. This is one of the main reasons, again, for the commissioning team to get involved early in the project is that feedback into the design is definitely valuable from a commissioning perspective. The design team may design and install piping and valves on paper, but when you actually go to site and you look at it, that valve is 4 meters off the ground and nobody can access it, nobody can operate that particular valve. Well, that's great, but during commissioning, you're going to need some sort of way to implement that, meaning either a pull chain or an access platform or something. Maybe that's what you're suggesting in your question there. So those types of things definitely can be are best incorporated in the design up front rather than the commissioning team getting to site and realizing there's no way to operate that particular valve. And maybe even more importantly for operation and maintenance going forward, there's no way to operate and maintain that valve during the course of the life of the plant. So definitely the commissioning team's feedback into that front end engineering design process, the feed process, is certainly valuable to make things easier and cheaper to execute later in the project. Some people may view that as an extra upfront cost, but if those things are added earlier in the project, they can save a significant amount of money for the length of the project, given the operation and maintenance of the facility. The commissioning team being the first ones to encounter those challenges, so it's good to get that commissioning feedback early in the process. So Pradeep has a question on, please share about functionality tests and cause and effect. So in your checklist and in your procedures, you have everything defined on what you want to verify and how you want to go through the commissioning and startup of the facilities. A lot of the functional testing will be defined in your commissioning procedure. Dependent on your specific project, the design team would have designed it to operate in a particular manner. And your commissioning procedure is going to want to execute all operating scenarios to confirm that the system functions per the intended design. That would be defined in your commissioning procedures. Now, when something doesn't necessarily work, there are a few methods that can be undertaken to troubleshoot those methods. One of those being cause and effect, looking through a very formal process of identifying what the issues are, what the potential causes of the issues are, and how those are affecting downstream processes. There's a few different methods to troubleshoot the systems using cause and effect methods, fishbone diagrams, and those are some aspects that we definitely go into more detail in our electrical and mechanical commissioning training. A lot of the issues, nothing is better than just getting out in the field, boots on the ground, and troubleshooting the systems to go through a process of elimination to find out what the error is. But regardless, the client or the owner may want a more detailed documentation process to show what the commissioning team is doing to actually investigate the problem and find the solution. And that's where some of these more formal documented processes may come into play to document the process that you're going through to troubleshoot the issue. Cause and effect being one of them, fishbone diagrams. There's a few different methods to go through there to produce that formal documentation to report outside the commissioning team of what's being discovered and what steps are being taken to address the issue. Question from Muhammad. During the commissioning stage, if there is a construction problem, is it possible commissioning team arranging that problem, or it must be construction team responsible? So that's always a discretionary call. If the commissioning team is going through commissioning and you find a rolled wire where the polarity is backwards and you just need to swap two terminals, you're probably just going to make that change. And when you're doing that, make sure that the red line drawings are updated to reflect that change. Simple minor change like that is just going to happen so that commissioning can proceed. A simple change like that would take quite a while if the commissioning team needs to step back, put in the paperwork, request the construction team, have them mobilize, come and make the change only for a 2-minute wire swap. Those types of changes are just going to take place so that commissioning can proceed. On the other hand, if there's more major problems with the installation and it's going to be, say, half day or even weeks to remedy, then of course that's something that the commissioning team is likely going to step away from and notify the construction team of the particular issue, where more detailed work plans might need to be established on how to actually address the issue, maybe even from a design perspective, and how the changes are going to be implemented in the field. So I would always leave that as a discretionary decision. It's something you can work out with your construction team to know that if it's a simple wire swap and the commissioning team has the screwdriver and can change the lugs on the terminal blocks and do it correctly, no problem. Likely those skill sets you have on your commissioning team. If you're working with some of the protection techs or electrical techs, they're journeyman electrician and they have the tools and ability to make those changes as part of your commissioning team. If it's a more involved change and the commissioning team doesn't have the tooling or the skill sets or the authority to do that, then certainly defer that to the construction team and they can get more involved from a planning and implementation perspective. Luvenry has a question. Does the commissioning team have to repair the device equipment if there is damage in the field? Because not all of the commissioning team understands electrical devices and equipment. Thanks. Yes, very much so related to the previous question is often those skill sets will exist on the commissioning team. If you're working on a large project like the one we just discussed, the commissioning team is fairly large, involving all disciplines from engineering to technicians, mechanical techs, electrical techs, operators. There was likely somebody on the commissioning team that had the electrical certificate or whatever was required and the tooling required to make the change on the system. That may not always be the case. If you're working with a smaller team, there may not be that particular individual that has the tooling or has the training and license to be able to make that particular change. So then, yes, for sure, you're definitely going to want to get those groups, the construction group or the design group, involved in replacing that item, particularly if there is a failed piece of equipment or there is damage, either forklift backs into a piece of equipment and causes damage kind of unrelated to commissioning, or on first energization, if there's a failed piece of equipment, there may be certainly more required to replace that device. If it's a large electrical apparatus, then yes, you're going to have to get some cranes involved and probably hoist it out of there, and that you're going to defer to the construction team. If it's a small circuit board that fails in a PLC rack, the commissioning team may be able to pull that out, swap it out, and replace it with a brand new piece of equipment to continue with commissioning. So hope that answers your question, Levenry. Question from Ixnolmar. I am an instrument commissioning technician. What is the most important system in a plant, and what part of a system is usually first to energize, commission, test? Another very good question, and this can be defined by the commissioning team, similar to the sequence that we talked about earlier in HVDC with regards to the AC systems being required first, followed by the synchronous condensers, followed by the HVDC. It's always going to be very dependent on your project. Often, though, a lot of the balance of plant systems are required first. So if you got the building and all the heating and cooling and lighting systems, those are typically required first because that's the shell, or that's the infrastructure that allows the construction and commissioning team to proceed with further on activities within that building. So some of the support systems are usually the first to energize and commission. If you're working in Canada here in particular in January, if it's minus 40 degrees Celsius out, in the fall time, you need to get the building enclosed and the heating up and running so that you can continue working through the winter. In the winter, the days are pretty short. It can get dark at 4:30 p.m. So you're going to need some lighting systems to allow the teams to be working through there. So typically the balance of plant items, those support systems or auxiliary systems are going to be what's required to energize, commission, and test first. With regards to the actual process equipment or function of the system, that's always going to be dependent on your project. So the commissioning team is going to want to look at the overall project and through the process of systematization determine what systems are required first. So often that's the electrical distribution system because power is required for further on testing of downstream systems. So say your project consisted of a chemical dosing system, you're going to want to have your electrical distribution system in place first before you're able to commission the chemical dosing system. And so the commissioning team going through that process and defining the systematization is going to define that sequence of what's required first and when what's going to be commissioned and tested first. Okay, I do see that we have a few more questions and we're getting a little bit short on time, so I'll see how many more we can answer, but I do want to leave time to show you how to get access to the certificate for, for participation in this webinar. So I'll answer this next question here from Amar Shawar. But in the factory acceptance test, they never involved commissioning, only QC and engineering design persons will go. Is this lackness in their industry? I can see that in some cases there seems to be a hesitation to get the commissioning team involved too early. Sometimes commissioning is an afterthought where the commissioning team is involved later in the process after procurement or after any of the factory acceptance testing has taken place. I discourage this because it is hugely beneficial to have the commissioning team involved in that factory acceptance test process. And I would like to see this happen more often. I know that there's pressure, there's cost constraints and resource constraints. It doesn't have to be the full commissioning team, but if the commissioning manager can be brought on early as well as a few of the critical leads, then those are the ones that it can at least participate in that factory acceptance test to have that knowledge and convey that knowledge to others that join the commissioning team after the fact. So it may depend on the industry, but I think across all industries, it is hugely beneficial to have the commissioning team involved in the factory acceptance testing. If they're not, then like you're suggesting, the QC team or the engineering team that did participate in that FAT then has to have very good records of what was witnessed and what worked and what didn't in order to pass those records to the commissioning team to address anything that's outstanding from a deficiency perspective or learn the equipment and what was working and what wasn't to hopefully make it work at site. So yes, I strongly encourage the commissioning team to be involved in factory acceptance testing. Question from Mel, when is the mechanical completion of the electrical system being recognized? Thus, it includes the factory acceptance test issues and closeout. So mechanical completion is the point when construction is complete. So it would capture any deficiencies that were outstanding from factory acceptance testing. It would also capture any deficiencies that are outstanding from installation. But then the deficiency list still lives and carries on past that point of mechanical completion. Anything that's discovered during pre-commissioning and commissioning is also added to the deficiency list and categorized as either type A, type B, type C deficiency, so that the deficiency list is a living document and continues to close out of the project. Obviously at handover of the project. Handover would be the critical milestone of handover to the owner, where a bulk of those deficiencies, particularly the type A and the type B deficiencies, need to be closed out. And then later on towards project closeout, the type C deficiencies are addressed as well. So I hope that answers your question, Mel. Maybe we got time for one more question from Carlos. Paul, in order to achieve successful pre-commissioning and startup, do you recommend any kind of life cycle methodology of project management? Scrum could fit with these stages. Possibly. I've always found that commissioning is very specific, and it's hard to shoehorn into a particular process. As soon as you try to process it, then that's removing some of the thought process or some of that dynamic thinking of the commissioning team, where you can't necessarily fit every situation into a defined process. I've worked through several different types of systems, and I've never found one that is a perfect fit. It really comes down to the integrity and accountability of the people involved to ensure that issues are being tracked and problems are being solved. When that's really what commissioning is problem solving. So when issues are coming up and they need to be addressed, how is the commissioning team's ability to think about those problems and troubleshoot in a unique and dynamic manner? There's really no process or flowchart you could say that if this problem is encountered, then take this step, because you're always encountering new problems and new challenges, and it's the fun part of commissioning to learn those new problems and challenges and find unique solutions to address those problems so that the project can proceed. So there may be a few more questions that are coming in here. Send them in and we'll see if we can get them responded to you. We are out of time for today. I actually have to go to our morning site coordination meeting to plan for the commissioning activities of the day on the current project that I'm working on. So we'll have to leave it there for questions for now, but like I said, certainly submit them. We'll gather them all up and we'll see if we can get you a response to your questions. If not, please join our next webinar. We're happy to answer questions like this. This has been fantastic questions, and I love this process to answer your questions. So keep them coming, and I'll see how I can help you out. But I do want to point to how you can get the certificate for this webinar, and that is at, this is a sample of the certificate. So this is what it'll look like when you get access to it, and you can access the certificate of participation at commissioningandstartup.com/webinar-cert. So write down that web address there, and when you log in there, you'll be able to add your name to the certificate. We'll date it and we'll email it to you right away. If you have any problems with that, contact us at support@commissioning.com and we'll help you out to make sure that you get a copy of the certificate. So thanks for joining today, everyone. I appreciate all the great questions. Our next webinar is actually planned for this time next week on August 20th. We will be posting this replay online, so you can check it out again. You can go through the question and answers that we've got here, as well as the presentation, and we'll send out links if you'd like to sign up for the next webinar on the 20th. Any questions that we can't get answered here, we'll maybe try and get an answer. If not, we'll maybe answer them in the live webinar on the 20th. And we're happy to have everyone here, and thanks for your participation, and have a great day.